to the Book Doctor channel. Here, we demystify mathematics and make it fun.
We are to find a general solution of the differential equation cos x dy dx plus sin xy is equal to 2 cos cube x sin x minus 1. We first have to identify the type of the differential equation given. The identification is the very first step in solving any differential equation, since the type will always determine the best approach in tackling the problem. This problem is a first-order linear ordinary differential equation with variable coefficient. A first-order linear ordinary differential equation with variable coefficient of the form dy dx is equal to some function a of x, y, plus some function b of x has the solution y is equal to c e exponent capital A of x plus e exponent capital A of x multiplying the integral of e exponent minus A of x multiplying the function b of x dx, where our capital A of s is equal to the integral or the integration of the small a of x with respect to x. We shall arrange our differential equation in the form we desire, this particular form. Let's do it step by step. We'll start by dividing through by cos x. dy dx plus sin x over cos x multiplying y is equal to 2 cos cube x sin x minus 1. This over cos x, this also over cos x. Sin x over cos x is tan x. So the left-hand side is dy dx plus tan x multiplying y is equal to, for the first part on the right-hand side, the cos cube x will divide the cos x and we'll have cos square x. So have 2 cos square x sin x. Then the 1 over cos x becomes minus sec x. Then we arrange it in such a way that the dy dx becomes the subject of the equation. So dy dx will be equal to minus tan x multiplying y plus 2 cos square x sin x minus sec x. Comparing to the form in which we want, our a of x will be equal to minus tan x, and our function b of x will be equal to 2 cos square x sin x minus sec x. Let's determine our capital A of s. Our capital A of x is equal to the integral of the small a of x dx. So this will be the integral of minus tan x dx. The integration of tan x is minus ln cos x. So this will yield positive ln cos x. Let's substitute the expressions we obtain. So this we see e exponent ln cos x, ln cos x plus e exponent ln cos x multiplying the integral of e exponent minus ln cos x multiplying the function b of x, which is 2 cos square x sine x minus sec x. Let's simplify the exponentials first. E exponent ln cos x by the rules of logarithm. E exponent the ln always cancels the exponential function, so they are inverse of each other. So this would translate into cos x. Then e exponent minus ln cos x will become e exponent ln, will take the minus to the other side, so we have cos x all raised to the power -1. So when the ln and the exponential function, the e cancels out, we are going to have cos x all raised to the power -1, or otherwise 1 over cos x, which can be written as sec x. So let's substitute these values into the equation above. So our y will be equal to c cos x plus cos x multiplying the integral of sec x multiplying the function b of x, which is 2 cos square x sine x minus sec x dx. Let's pick the integral, the integration portion, and work out that. Then we'll come and substitute back. So we have the integration of sec x multiplying 2 cos square x sine x minus sec x dx. We'll simplify the expression before we start integration. So the sec x will multiply the first expression. Remember, sec x is 1 over cos x. So when we multiply it by the first expression, the cos square x over cos x will give us cos x. So we are going to have 2 cos x sine x. Then the sec x will multiply the sec x. We'll have minus sec square x. We'll split our integration into 2 parts so that we can do them in a more comfortable way. So we'll have the integration of 2 cos x sine x dx, and then minus the integration of sec square x dx. The integration of sec square x is tan x. So this is 2 cos x sine x dx minus tan x. We do not need to add the constant of integration. As I said, it has already been dealt with. So now we know one part of our integral. is left with this very portion. We shall also look at that one, and then we'll come and fix everything back into our formula. We can bring the 2 outside the integral to have cos x sin x respect to x. Now we are going to employ the u substitution, algebraic substitution. We'll let u be equal to sin x, then the u dx is equal to cos x. Then we'll make the x a subject. The x will be equal to du over cos x. Then we substitute this into our integral. So this becomes 2 multiplying the integral of u cos x du over cos x. Then the cos x will cancel out. Then we have the integration of u du, which becomes u squared 2u squared over 2, or otherwise just u squared. We'll bring our actual expression for the u, which is sine. So our integration will yield sine square x. So we'll put these values into our formula over here. So we have 2 items to substitute: the minus tan x, and then the sine square x. All of them will enter this box where they will be multiplied by cos x. So let's proceed. Our y is equal to c cos x plus cos x multiplying sine square x minus tan x. Remember, that is the result of our integration. Let's go back and check the whole integration here. One part was minus tan x, and the other part yielded sine square x. So let's perform the multiplication. We have c multiplying cos x. Then we open the bracket. We are going to have cos x sine square x, then minus sine x over cos x times cos x. We have just converted the tan into its identity. Let's continue simplifying. We have c cos x plus cos x sine square x minus sine x, because the cos will cancel out the cos over here. Ideally, this is the general solution, but probably we would like to massage our expressions a little so that at least we can have a more simplified, compact version. So what we'll do is that we introduce some identities. So we'll introduce an identity for sine square x. So we are going to have the constants multiplying cos x plus cos x multiplying 1 minus cos square x minus sine x. Opening the bracket, we'll have some constants multiplying cos x plus cos x minus cos qx minus sine x. These two are like terms. We can factorize cos x out. So c plus 1 cos x minus cos qx minus sin x. Since 1 plus c plus 1, since c plus 1 is a constant, we can make life comfortable for ourselves by saying that c plus 1 is equal to some constant a, so that we can write our solution in a more compact form. Y is equal to a cos x minus cos qx minus sin x. This becomes the general solution for our differential equation.